The game I've made is a game where you control a square and you have to move this square into other boxes in the 3D space. You can only pick up the boxes that are smaller than you, and the ones bigger than you will get you killed. You have to be totally on top of the cube to consume it, and let's have a look at what happens when you die. It then goes to this game over screen, which shows the score you made this game and a list of high scores, not including the one that you just had. And if you press the R button, it will reset and you can start over again. If you win, you will be taken to almost the same game over screen, except that it says congratulations, you won, and show the score and high score again. To move on to explaining the code, since it is we are using the Open Frameworks EasyCam as our base, we have the setup, the update, the draw, key pressed, and all of these in it. I then made a struct to contain my enemies, which define their x, y, z values and how big they are and whether they are alive or not. I'm then making a pointer of these and a temporary of these. Yeah, and I make two of these structs a pointer so that I can make a dynamic array of enemies, and a temporary since I am swapping some of them around later on. I then have a if stream, which is used to open files and extract data from these, and an off stream, which is used for, well, opening files and saving data to these. And I then have a string that I used for saving this loaded data from the if stream, so I can put it into the off stream together with new scores. I then have some basic integers, how big our player is, scores, how many enemies are left, and so on and so forth. And inside my code, we start off with the setup, setting up all the basic values. In our update, we have our collision detection, where we are going through all of the enemies and checking if their X is close to your player box's X and Y and Z and so on. And it's basically checking if it's less than 10 or bigger than -10, so it gives you a buffer of plus minus 10 pixels from the center of each box. And the cam set distance up here, what it does is to set how far away you are from the 0.0.0 along the z-axis. Yep. And what we do with the collision down here is we say if player size is bigger than the enemy size, the enemy will die its alive will be set to false. The player will grow a little and you will get some score added. But if you are smaller than the enemy boxes, your alive will be set to false, which means you are dead. We then go down here and say for each of the dead enemies we subtract 1 from enemies alive. And yes, then we have one down here which is for sorting the enemies so that the alive ones will be on the first spots in the array and the dead ones will be on the last spots in the array, which means we can run our for loops through fewer times each time, since we can reduce the maximum value of the for loops, as all the dead enemies are on the last spots. We won't need to look those through as well. So we just go through them all and say if they are dead, we subtract 1 from the maximum value. And if if there's no enemies left, your alive will be set to false, which basically is just for stopping the draw function from drawing all the boxes and instead going to the dead one, just printing out something slightly different than if you were dead. So yeah, in our draw function we have start off with an if, saying if you are alive it should draw these. We then have can begin, which the can begin and the can end are used to separate the piece of code that should be in the camera coordinate system instead of the window coordinate system, which means it is in the 3D space when it's inside these, otherwise it's just in the 2D window that we normally use. It then sets the background color to be black, set the color of your own box to be red, spawn it at these positions, your own x, y, and z value with a certain size, and gives you a border as well with no field that's black. And we then say if the enemies haven't been spawned yet, if spawned is just equals false, it will make a random amount and create an array containing this random amount of enemies. We then give them random x, y, and z values and give them a random size and set them to being alive. And we then say they are now spawned, it should not run this again. Then we start drawing the enemies. We set a color for each of them, which I've chosen to give them various levels of colors depending on their size. So the bigger they are, the darker they will be, so it's a bit easier to see which one is bigger than yourself and which aren't. And we then fill them out with these x, y, and z values we've just made up here, and the size that we've also defined up here. And we also give these a black border. We then end our cam, since we're no longer working with things that are being drawn in the 3D space. And then we start printing out some text, just some basic instructions, the score, and how many enemies are left. We then go down here to this else is connected to the alive. So this is basically what will happen when you die or win. It starts off by saying if this is the well, since this is in the draw function, this will be run through every frame, which means that we'll have to say that the first time it runs this through, we have to load in these things and not every frame. So we have a boolean that's called first death, which is where we open up the highscore file, we load in the data from this file, and we then close it again to make sure that we don't overwrite any data. We then go down here and say if the score is bigger than 0, it should add the things that's already in the file, as what this function does is to overwrite the whole file. So we want to keep what's already in it and then add our new score to it, and then we close it again to save these changes. We then make a temp string that's equal to what we already loaded in from the high score, and we set a value and a score list to be nothing. We then run through this temp string, and we load it into the stream, and we then save this stream in numbers. So it takes numbers until we hit a space, as the way we are loading in scores is with 2 spaces between each. So it can say when it hits a space, it is then done loading in this number. Yeah, so we have this array of numbers that we are loading the values in from our text file, and we are then deleting this data from our temp string so that it won't bring the same numbers all the time, but they will move further into the temp every time. And yeah, we have to know how many digits is in the number that we've loaded in, because we know to have to know how many spaces we have to delete in this temp string. And since we have 2 spaces between each, we have to start this count at 2 and then divide the number by 10 every time, and every time we divide it by 10 we add 1 to the count, so we know how many digits is in this number. And we have a variable to go through all these numbers. We then go down here and we run through our number array and well, bubble sort them. Chosen to use bubble sort since it is quite fast and effective with few amounts, and as we only need to well, since we only need quite few high scores to be run through in this program, it seemed like the best option. And after we've done this, we load in the 10 first values into our score list string so that we can print it out, and we set first death to false, since we are now no longer loading, we no longer need to load in data for the file. And then down here, if there's no enemies left, which means you won. It will print out congratulations, you won, and our score and the high score. And if there were more than 0 enemies left, you would get game over how much you scored and the high score. What we have in key presses is this with M. There is not one I'm using. Should delete that instead. But as you can see, we are moving forwards and backwards along the Z axis, which is where we are looking from. Using W and S. We have our R button that resets the levels, setting all the values to their basics, so it starts spawning new boxes and sets you to being alive again, sets your score to being 0 and all this. We then have D and A to move along the x-axis and and space and X to move along the y-axis. And we have a F to toggle full screen. And yeah, that's basically my code.